I'm going to go ahead and get started. My name is Randy Syring. I am the Chief Executive Developer at Level 12. We are a local Python, well, I guess we're a software development shop. We use primarily Python on the back end. I personally really love Python. I think it's a great all-purpose language, maybe one of the greatest all-purpose languages, including Haskell, as if Haskell was a general-purpose language. Anyway, one of the things that we're trying to do with DerbyPy is we're trying to have an initial 15 to 30-minute talk that's really geared towards beginners, trying to explain some of the more basic concepts in Python, and then the main talk of the evening will be of various levels. I think today it's going to be a little bit more for beginners as well, but sometimes, is Alex here? I don't think I saw Alex. Alex did one for us last time, I think, and wasn't his last time? Yeah. Yeah. And oh, that's right. Yeah, he told us about that because he was supposed to do the beginners talk, and I'm doing it instead. That's right. So Alex did one that I think went pretty in depth. It was introductory, but there was a lot to it because it was a distributed system, and there's a lot that goes into that. So just to give you a heads up in terms of what we're doing, we'd like for the beginners of you to always feel like you can come and there'll be something here that you can understand, even if the talks that come later end up digging into a lot of details that go over your head, which I just want to say is you shouldn't feel bad about. You're beginners, right? You're just starting to learn, and even the most experienced of us get into something sometimes that it takes us a long time to work out because we have to learn it. And there will be, that's actually some of what Nick's going to talk about a little bit here in the next talk. So one of the things that I've been trying to do in these beginners talks is I've really been trying to demystify kind of Python packages, modules. Today we're going to focus specifically on how you install a package. In essence, what I'm really trying to drive home is that all of this stuff is essentially files on the file system. You just have to know where to go to look. And once you know that, once you understand that that's really at the heart of the system, it makes debugging a lot easier because you know where to go to see what packages are installed. You know where to go to see if maybe the metadata has been corrupted. You know where to go just to delete everything so that you can start again, because I've had times where I'm not even sure how something got in the state it got in, but all I want to do is blow away my virtual environment and reinstall everything, and then it starts working. So a lot of times if you get something weird going on that feels like it might be related to package installs or whatnot, then blow away your virtual environment, start over, reinstall everything, and you'd be surprised at how many times that just ends up fixing something. Any initial questions about that? If you have a question, feel free to interrupt me. I like dialogue. Yes, sir. Okay, so I'm only going to touch on that briefly just because I don't want to take too much time, because I think I'll take all my time for the install. But essentially, I'm using VS Code, which is a Microsoft product. It's one of the few Microsoft products that I use that I like. It's great. It's open source, and they've done a great job with it. I think they're heading in the right direction. And I think some of us use Sublime, which is another editor if you're interested. Atom, I think, is another open source one. Some of us use Vim. But yeah, so just finding a good editor, I'd recommend this. I think if you're really looking for an IDE, something that's a little bit more robust and kind of understands Python a little bit better, you could use something like PyCharm. Personally, I don't like all the magic in those type of editors. I want something really simple. I just want to deal with files and then get a little bit of help on syntax and linting. So for me, VS Code is really the sweet spot for all of that. I'm just using a terminal here. In the code, the tools I'm going to use to help set up my virtual environment are pipenv, which kind of handles both pip and virtual environments, and we'll also use pip, which are part of the Python ecosystem. You can Google all those things. I'm not going to go into too in depth on them just because I want to focus on something else tonight. Any other questions? Yes, sir.
So, like, using Pigeon for virtual and how is there much difference from safety conduct?
You know what? I don't use Conda, so my guess is probably not too much. Obviously, some of the commands and where my stuff is stored on the file system is going to be different, but I would assume that the principles are similar because ultimately the stuff all has to hook into how Python sets up its syspath, and I think there's a relatively limited number of ways to do that. So I think the concepts are going to be shared. And if you find out differently, feel free to let us know next time you come back, and I'll recant. Anybody else? Okay, so I already have a virtual environment active. You would see that, but I changed my prompt to remove that for the sake of clarity here. But I do have a virtual environment activated. That virtual environment, the root of that virtual environment is here. So I've customized where my system saves virtual environments. And then pip-env automatically set this up for me, set up this directory. And you'll see that there's relatively few number of files in here. I'm going to actually dig into the live directory and then Python 3.6 and site packages, because this is really where all of the install stuff that we're going to do really comes into play. So I'm going to leave that open. The other tab that I have open here is to my project directory. This is where my source code is and kind of my working directory. So if you see me flipping between those two tabs, this is the project directory again, and this is site packages, which is inside of my virtual environment, or is the site packages that applies to my virtual environment. If you're not sure what a virtual environment is, just Google it and read. It's an important concept to understand in modern Python app development. Okay, so the first thing that I want to do is go back. I actually showed this the last beginner talk that I did, but I want to show that I want to show you what sys.path is here. And it's really important to understand because can't type and talk. Give me just a second. It's really important to understand because sys.path is where your Python executable, where your Python process is going to go to look for packages. So when you say import click, which is a package we're going to use here in the future, or you say import Django, or you say import Flask, or you say import pandas, it needs to know Python. That Python process needs to say, well, where do I go to look for pandas or Django or Flask? So it looks in sys.path, and you can inspect that. So if you're trying to debug and you feel like you might have a path or package problem, the very first thing you should do is make sure that your sys.path is pointing to something that makes sense based on what you expect in your virtual environment or what you're trying to do. So the key thing here for what we're going to look at is that the last entry points to that virtual environment directory, the site packages directory that I showed you. So what I've got highlighted is this. It's this path. And that's why when I start changing and putting files in that folder, the Python that I'm currently using in this virtual environment is going to see that stuff because that folder, that path directory is in sys.path. That's not helpful. Okay. Technical difficulties. Okay. So again, sys.path is really important. The first entry is also important. It's empty. That means it's going to use the current working directory that I'm in when I call Python as part of the path. I'll show you how that might create some confusion here next. So I'm going to exit the REPL. And the first thing that we're going to do, so again, I'm in this directory. You'll see that I have hello.py here. This is the same directory that my editor is set up in. And so at the beginning, all I have to start with is a print statement, and I simply want to import that package. So to show you that that's where I am, my terminal is, and now I'm going to -C means run this code as if it was a script. and I want to import hello. And it imports that module, it runs it, and it prints the statement.
You have multiple versions of Python, so how do you know what Python is doing?
Yeah, that's a really good question. So Python -- version would show you. Unfortunately, that's not going to show you if you're in a virtual environment. So I would say that managing your Python, which Python you're using, and which virtual environment is active, and which Python that virtual environment got created by. So when you create a virtual environment, the Python that you're using, unless you give it a different command, a different option, is going to be what controls the Python version that's active in the virtual environment. So that's a bit outside the scope of this. I'd be happy to talk to you after, but you can use a tool called Python and Py.
Yeah, PyAms is a way to manage Python installation. That's
Yep.
all way to do it. But I mean, the short answer is your bash, your whatever your terminal is going to look inside of its own path to find the first executable named Python.
Yep.
So it's kind of outside the scope of Python itself. It's happening in the terminal layer.
Yep. Okay, so notice that I imported hello. Yes, sir.
Where's the heavy lifting done on the resident machine?
Yeah, this is all local. So I did Python import hello. Hello is not part of the standard library that is picking up the file that's in my current working directory. The reason that that can be confusing is because it might work here, but let's say I had I needed to change the directory that I was in for some reason for something that I was trying to do, but I still want to import hello. Well, now it can't find hello. And the reason it can't find it is because it was using the current working directory. I just changed out of the directory, and there is now no hello file in this directory. So that can be really confusing. You could be importing something, it could all be working. You could change the working directory of your prompt, run the command again, and all of a sudden it can't find a module that it could find before. Well, it's probably because you might have thought you installed it, but it's really picking out of the directory. So I'm going to change back in here now. Actually, no, I'm not. I'm going to stay. So what I'll show you, the first thing that I want to show you is that installing a package so that Python can find it can be as simple as copying a module over to the site packages directory. So I'm going to grab this hello file. I Control-C it. I'm going to Control-V it in here. And I'm going to run that same command that I just ran above. And now it's going to find it. And the reason that it found it is because I put that hello.py file in a directory that was in sys.path. So it went through all those sys.paths. It looked for a hello.py. In the last one, it found it, and now it can import it. One of the difficulties with this, though, is that if I was to come in here and say hello Randy now, it still says hello world. Why is that? That's right. I changed my original, not the copy. So in Linux, this could be relatively easily rectified by creating a symlink. For those who don't know, a symlink is essentially a file-like object that points to another location. So now Python will find what I want it to. It'll say hello Randy, and I can change it back to hello world. Python is still finding that file. In fact, let me show you that. Notice Python is still thinks that file, it's finding it in the virtual environment site packages directory, even though it's a symlink. And for what we're doing right now, this could be great. No problem. It works. I could continue to develop, and it would be fine for the moment. There's easier ways to do that, though. I'm trying to show the principle at this point. Okay, so now that we have that file symlinked, I want to talk a little bit about dependencies. So I want to now create a really small CLI application, and there's a really handy library in Python called Click that makes it really easy to create usable CLIs. So I'm going to run my import statement again. And now we have a different problem. The problem is that the dependency, the click dependency, is not, Python can't find that. It doesn't know what to do when I say import click, because it doesn't know where to find click. If we look at our site packages directory, we'll see that there's nothing called click in here. And apparently it's not a standard library either. There are some things you could import. So I could, for example, I could import the zip package from Python, and that's in a different directory. It's not in my site packages. That's part of the standard library. So what I'm going to do is I'm going to go to PyPy, which is the Python's usually typically the repository that everybody uses to publish packages, unless you have a reason to publish your own locally that are private. And I'm going to search for click. And I'm going to go to the download files. And I'm going to download this archive file. Save it here in my directory. I'm going to unzip it. I guess it's not called unzip if it's a tar file. And then I've got a directory in here, and you'll see that there's a click directory in here. Now I know how click is set up. I know what it's going to do. So I'm going to take that click. I'm going to put it in site packages, just like I did earlier with my hello file. Copy and paste. And now if I try to run this, it runs just fine. So again, to install a dependency, all I had to do was to get the files and move them to a place on sys.path for this Python process. Okay, relatively simple in terms of moving files around, but a bit cumbersome, especially if you've got a lot of dependencies, and those dependencies have dependencies, not really what you'd want to do, but at least you understand the mechanism, the tools that I'm going to show you next, you understand what they're doing, which is really all I'm trying to show you. So now that click is there, I want to introduce a tool called pip. If you're not sure what pip is, yes, ma'am.
So are these packages dependent on the version 5?
All of the packages that I'm writing right now are Python 2 or Python 3 compatible, usually Python 3 or 4 plus. Actually, my module would probably fail on the, oh no, actually my module would work. I had a print statement in there earlier that was a function, and it would fail on Python 2 unless you imported the print function from future. But yes, for the most part, the stuff that I'm installing is going to be cross Python compatible. That's not always true of all your dependencies.
So I mean, you can find a lot of different and the versions, but 2 or 4 is different.
Can you ask the question a different way, maybe? I'm not sure what you're asking. Okay, sorry. I'd be happy to follow up with you afterwards. Okay. So one of the tools that we have to install packages in Python is pip. Again, I don't want to really do an introduction to pip. There's a lot of good information out there. Google it, find the documentation, read through it. It'll be really helpful. But one of the things I want to introduce you to is the freeze command. And pip freeze will tell you what packages are currently installed in your environment, whether it's the system environment or the virtual environment. And unfortunately, pip doesn't see any packages installed right now, even though I have technically my hello module and click installed. And the reason for that is because a Python module and a Python module's metadata are 2 different things. And so pip is looking at the metadata, but I don't have metadata for either of the things that I installed. So to show you an example of that, I can take this egg info directory and I can paste that in. And the egg info directory is a directory with metadata in it. And now I can run pip freeze and it at least sees click. So again, these are just directories and files put in a location that these tools know where to look for. So if you're trying to troubleshoot, you yourself can open up the browser and start looking at those files and trying to troubleshoot. Pip also has an uninstall command, which is usually helpful. But in this case, the metadata that I copied from that archive is not really the correct metadata for the installation that I just completed. And so what I'm going to do is I'm going to actually use a different method to install click. So I am now in Click's directory. Click's the extraction of what was in that tar file that I downloaded. And now one of the most common ways to install a Python package is to simply download the source and then run Python setup.py install in the root directory. Now, if I look at site packages, we'll see that I have a .egg file. A .egg file is really just a zip file with a very specific format. You can open it up and explore it. Essentially, we have the Python code, the source code, and the metadata. So again, it's packaged a little bit differently this time, but it's still the exact same thing. Okay. So thankfully, pip now recognizes the install. It also will hopefully be helpful in, because our metadata is now correct, I can use pip to uninstall it. It'll tell me what it's going to do. That's exactly what I want it to do. And so I say yes, and all it did was delete that egg file. Okay, a third method of installing, I'm going to change directory out, and so now I've got that click directory exposed, or I'm at the same level. And so I can use pip and point pip at that directory, and it sees the setup.py file. That's interesting. All right, I thought I could do that. So we'll install inside that directory instead. Pip knows what to do with the setup.py file. It installs it. Interestingly, pip does something a little bit different. It doesn't have the egg file. Instead, it explodes them. There's no unzip step needed. This is the source code, and the metadata is sitting right next to it. This time, if I do it, because I've done it before. So yeah, pip does do caching. So if you install Click, if you've got 7 different projects that need Click, the first time it downloads that wheel, which is kind of the archive, it'll store that locally, so that if you have other installs of Click, it won't have to go out to the internet and download that blob again. It'll just use the one that's been cached locally. So if I wanted to, I could use pip to uninstall Click here. I'm not going to do that. I want to keep it installed. I just want you to see that Click pip recognizes now that instead of a .egg file it needs to delete, now there's actually 2 directories that it needs to delete, just because it was installed with a different format. All right, any questions about this so far? Okay, so it would be nice if we could, rather than having, if you remember earlier, I created a symlink in order to get my hello module recognized. It would be nice if there was a relatively easy way to get my own package installed in such a way that Python could recognize it. So one of the ways that we can do that is to add our own setup.py file. You'll see that I have that file created. I've stripped this down to the very bare necessities that you need. You'll notice that I reference my hello file. You'll notice that I also say that it requires Click. And I've also created an entry point, which is going to create a executable in my bin directory, which will allow me to, rather than having to type Python and where the script is, it'll just give me an executable, that I can run from the command line, which can be really helpful. So without going much into details into what the setup.py file is, I actually did want to delete Click. So notice this is site packages. Click is gone. Make sure I'm in the right directory. My Python hello.py is there. So now I'm going to run Python setup.py install. And when I'm done, you'll see that I have the Click. Okay, interesting. That's a third package format. But I have Click here, and you'll also see that I have my hello module here. And so now I should be able to, I guess I could show you one other thing. I also, in my bin directory of the virtual environment, I now have a hello binary. If we open that up, you'll see that it's really just some Python code. It's not an actual binary. You could open that up and look at it and figure out what it's doing. So go back to site packages. And now, for the sake of argument, I'm going to go out of my project directory. I'm going to type hello, and hello works. And I can now type hello, hello again, because I wasn't very creative with my subcommand names. And so I've got hello world. All right, what's the problem here? We have a similar problem here that we had earlier. Is this going to work? What? It doesn't. It doesn't work because the setup.py install command copies everything. So if we go and look at site packages and we open this egg file, we'll actually see there's a copy of hello.py in it. Well, that's not really helpful if you're trying to develop something and you're trying to iterate. Like, I don't want to have to type python setup.py every single time that I make a Python change. I just want to make it and I want to run it, run my change. So thankfully, there's a different command that we can use. I need to go back to my directory. I can do, if you remember correctly, last time I ran setup.py what? Install. This time I'm going to run setup.py develop. And now when we go back to site packages, oh, that's kind of ugly. We shouldn't have two there. That would be a good source of confusion for you. I'm not actually sure which one it would use, but if it was picking up the egg first, that would be really confusing. But now you'll see that I have a .egglink file instead. And if we open this up, this is really just a text file that points to the directory that package lived in. So Python knows what to do with this. It will now, you can change your local files at will. And it will have, it's essentially the same as a symlink at that point. Okay, let's see. Setup.py, binary. I think I showed everything I wanted to show. Questions?
So much to type Python setup.py develop. Is there a way to do this with pip?
I did want to show that. Thank you. I knew I was missing something. So we have Python setup.py install. We have Python setup.py develop. The equivalence with pip, delete that, delete hello.egglink. So we're back to essentially what a started, a virtual environment, a new virtual environment would be. We're back to that state. So now I can do pip install dot, which is what we did for click. I won't do that again. If you remember, we did that for click. We just changed directory in there, pip install dot, and it installed it. If you want an editable install, which is kind of what we had with that egg link, it's an editable install. It's what Python setup.py develop did. You just pass -e. It's probably -- editable for the long version. And dot. And then instead of installing, it's going to give you the egg link. And now you're free to move on and develop to your heart's content. Questions?
Note this could be relevant if like you have a kit for like tracking file changes. If you look in the local directory, if there is an actual egg folder that's created locally.
That's right.
I was thinking of hello egg, but
I'm sorry. I thought I was up a directory. That's what we wanted right there. What is that in? Package info? I don't even remember.
so this is just all the metadata for your hello package.
I didn't find a hash anywhere, but it's fine. Okay, thank you.